Welcome everyone. I'm Charles. I'm going to be running this workshop here on engineering a tiny little LLM application for chatting with MLOps World data. So there's two QR codes up here, one for the slides, one for the code. In my experience and what I've heard from people from yesterday, trying to like clone a repository and spin up a bunch of services on hotel Wi-Fi is not a great idea. So rather than trying to like code along as I'm going, I would check out that repository later if you want to like actually execute stuff. There's a GitHub code spaces associated with it, so you've like guaranteed executability, and I will respond to any issues or questions if you get stuck. But rather than trying to do that live, I'll go through everything live, and you can ask me questions. You can ask me to rerun something, and we'll make sure that we all have like the most valuable experience possible with the technical capabilities that we have. All right, so retrieval augmented generation chatbots are like the to-do list app for large language models. So who here has ever built a to-do list app? Maybe anybody who's done like a front end or maybe full stack JavaScript development. Yeah, so it's like pretty common like portfolio piece, pretty common like project that is done by people learning front end, because you have to, actually full stack web development, because you got to store some information and retrieve it. You got to be able to create, read, update, and delete information. You got to have to display it in an interactively in a browser. And so it gets, it's not the most useful thing in the world. It's not the most exciting technology in the world, but it touches on all of the, like a lot of the different pieces that are necessary to build an actually useful web application. Like one of the delightful MLOps tools that's being vended downstairs, like Aporia or Neptune or whatever, not so different from a to-do list app in some ways. So these chatbots that retrieve information from external locations are kind of the to-do list app or the pet store example for this new technology of large language models. And why are they, why have they taken off, or why are they such a good kind of hello world example? Because language models, provided by foundation model providers, lack context. They don't have any information about the person that they are interacting with or about the system that they're embedded in, and so they give they give poor answers if you try and use just the raw GPT-4 as your support bot. For example, I remember around when LangChain came out, I was ran like, ask GPT-4, what is LangChain? And it was like, LangChain is a method for doing language learning on the blockchain. And turned out that was actually true. There was a company called LangChain that was using language learning on the blockchain, but that was not what I wanted to know about. So in the language models lack context, and so we have to, if we want to use the current crop of language models effectively to interact in a contextual environment, which is almost all environments, we have to ask users to collect it, or we can collect that information for them. And if we're going to do something valuable for users, we should be the ones collecting information for them, not asking them to copy and paste information. So the solution is store the information somewhere, index it in some like fast indexable way, and then inject it into the prompt. So the application that we're going to be talking about today is something that I built for the full stack LLM bootcamp that answers questions sort of all around LLMs, machine learning in general, MLOps. There's a Discord bot. I think there's a link in the code repo if you ever want to check out the like full application in its production version. But this general pattern of storing, indexing, injecting into prompt has like it doesn't really have that much to do with any particular format of data that you're interested in, so it's really taken off. There's like a million different tutorials that are like, here's how you can chat with your documents. Here's how you can like put some tools together and be able to like talk with your PDFs or your Notion documents or whatever. And kind of the gap between a lot of these tutorials and actually delivering a valuable LLM application, the gap is about as big as between this first step and second step of this owl drawing tutorial. There's a lot of care and thought taken to explaining what a vector index is and a language model and the transformer architecture, and we draw these two beautiful circles, and then it's like, okay, well, how do I go from that to something that somebody's going to actually like use, care about? There's a lot of stuff to do. So we're going to talk about some of that stuff. I'm going to like kind of focus a little bit on some of the tooling that I think is most useful for this process. Some of the patterns that are most reproducible, like from project to project, on actually closing this gap. So what I'm going to do is I'm going to walk through the process that I used to go from the initial version of this chatbot on the full stack LLM Bootcamp, full stack deep learning dataset, and I'm going to add the dataset, a dataset from MLOps World talks. So this talk's being recorded. It'll be uploaded to YouTube. There's a bunch of talks from past MLOps Worlds uploaded to YouTube. Let's add those as sources for this chatbot. And then I'll walk through the process of adding that new source and show sort of like things that were updated and changed and added sort of like instrumentation on making use of this data, and then we'll see a deployed example that you'll be able to interact with, and then we'll collect user feedback on the responses of this model. Great, and the theme, or one of the like core takeaways from this is going to be that the most important thing to do in like taking an LLM application from just okay to really great is like an obsession and a focus on the data. A lot of people just want to kind of like hook up pre-existing tools, like, oh, I'll just like grab this, scrape the web, throw it into a database without any thought, pull it out of the database with like standard tactics, like never look at it by eye, like hand it out to users, and never. A lot of people, software engineers, not data engineers, why should I look at data? That's, beneath me. But looking carefully, we'll see multiple examples where sort of like looking carefully, spending some time with the data brings a lot of benefit. Okay. All right. So now we'll switch over to the VS Code demo portion for a bit. That should be big enough. All right. So I'm going to walk through the process for adding some MLOps World data, getting information we've got these videos on YouTube from past instances of MLOps World. Let's get this into our chatbot's memory, into its storage. So there's 4 playlists from. I looked around at the MLOps World YouTube channel, and I found about 4 playlists that seemed like they'd be relevant with relatively fresh information from the 2021 and 2022 editions of the conference. So I looked around and I wrote them down in little locally stored JSON blob that's got the information about these playlists. I want to grab all the information for them. Looked around, and the talks are about lots of MLOps, relevant topics for MLOps. Some of them are tutorials like this one. Some of them are more like vendor talks. But generally, they've got a lot of concepts and ideas around MLOps that aren't covered by the course material and the like research papers that are currently indexed. So these look like some useful new information to add. Let's take a look at one of them maybe. The 2022 conference talks. Use one cluster to rule them all, ML on the cloud using Array on Kubernetes and AWS. That sounds like some useful information. We should definitely index that. All right, so what's the plan of attack for getting this into a format where we can retrieve relevant information and share it with our chatbot? So we have I was able to, at the very beginning, just like by hand looking through this data source and being like, okay, here are the playlists, here's the relevant stuff. So there's a sort of step at the beginning that's like, take a look at the available data. Maybe there's some like free APIs we can download data from, and you can find like on social media, on blogs, whatever, like a list of sources, some information. That's the kind of manual step. And then after that point, you want to kind of try and automate everything after that. So what do we want to do? We want to get all the videos from the From the playlists, we want to get subtitles from each video. These are, the videos are images and audio, and humans can process that pretty well. We don't really have language models or multimodal models that can handle like hour-long videos and extract information from them reliably. It would be also more expensive, so we want text data. And luckily, YouTube videos come with automatically generated transcripts, so we can pull that down. We're going to find that we need to do we pull down that we're going to get all these transcripts, and then we need to do a little bit of massaging in general. We're always going to need to like transform the data after we pull it out. And then we're going to need to load them up into some storage solution. And at this point, we're looking at, I already have a bunch of other things that I've loaded in I've loaded some markdown files from GitHub repositories. I've loaded some PDFs from Archive and other paper stores. And like, if I were trying to put this all in a single project, then I would be like, I'm starting to run the risk of hitting like Python dependency conflicts. So, and a lot of these are like, we need them for this like small little task, and Python is great for having these little libraries for doing small little tasks. It's not great on the dependency management. So we want a solution where we can like avoid putting all these in the same environment. And you might want to reach for something like, setting up little containers, doing a workflow orchestrator. That's definitely a great option. The way that I like to do it these days is to use this tool that recently became generally available and exited beta, Modal. Let me show you the website real quick, modal.com. So Modal lets you like sort of Pythonically define containers and applications built out of those containers. So rather than needing, look mom, no YAML is one of the slogans. So rather than needing to define a Docker file, then like maybe define a bunch of Kubernetes objects, spin all that up. It's this cloud service. They'll run, you define the containers in Python, they'll run them for you. And we'll see a bunch of different features as part of that. So just recently became generally available. I love this tool. I specifically turned down an opportunity to angel invest in it because I love it so much. I want to be able to recommend it to people at places like this and not have you think that I'm just trying to, scam you, make a quick buck. So Modal, we're going to be defining images that our code runs on. So for example, we'll say, so the first thing, broken it down into a couple of different container images. One of them is focused on these YouTube videos that we're going to be downloading. So it's got subtitles. Right here, we got the actual sort of like commands that help build this image. We can see that we do a pip install and we bring in this subtitles file or subtitles library and this YouTube transcript API. I can actually, let's just hop into the code real quick and take a look at how that happens. So we can start, we can manipulate these images in Python. So it's, so I can start with some like image definition, and then I can say, oh, on top of that like base image that I know all of the pieces of my application are going to share, or all the pieces of this extract, transform, load part of my application are going to share. Let me just add this little pip install command. And we can go one level deeper if we want to see like how this was defined. You can define them from a Docker file if you want, but it can be nicer to just sort of use some of these like abstractions, like just give me a nice like Debian image with Python 3.10 on it. I don't know, in my experience, it's just like, find somebody who's got a nice Docker file that's like close to what you want and go off of their image anyway. And this is not that different from that, except that it's, managed in Python. So this is our image. An application is built out of an image by combining that image with like configuration. So things like mounted volumes, so like network storage, secrets, and then these are the things that we'll manipulate for our like application, like deployment and lifecycle. So that would be, for example, this stub built out of our YouTube, or the image that has our YouTube dependencies, this stub adds on top of that sort of like default image some secrets like how to connect to our database and some mounts like some of our like local Python code. And I think, yeah, maybe not no network storage. We'll see some of that later. Great. Yeah, so there's a ton of depth, I think. I sort of think of this a little bit more like a runtime, right? So when there's a certain kind of like fundamental like base layer technology that gets called a runtime, where it's like you take some description at a high level and it converts that into something more concrete at a lower level, like JavaScript runtime takes the like high level JavaScript code that you write and turns it into like virtual machine code. That those runtimes tend to be like very flexible, very powerful. Whenever a new one comes out, it opens up new opportunities. I think of Modal as this sort of like runtime for serverless Python. So there's a lot of depth that I'm jumping over here. They have great docs and explanations where you can see all kinds of different ways to use this tool. The important thing for right now is that with our stub, we can run Python functions that we're defining locally on on Modal's infrastructure in these defined containers. So I've defined a bunch of functions that we need for handling these YouTube videos, like getting transcripts, getting the subtitles, and sort of managing them. A lot of sort of like hitting the API to get information like chapters, and like turning it into the final format that goes into our document storage. So these instructions go through like how to get things set up, including how to make an account and authenticate. If you go through this tutorial or example later on your own, all the stuff is kind of managed by this little make file that has these targets and some help explaining how these work. This also manages your like authentication with the various cloud services that get used. All right, so let's any questions before I move on about the tool stack, about the application? Yeah. Yeah. Let's just. Yeah, so two questions. One was, you're using this like Debian image. Can you configure? How much control do you have over that? And then the second question was, what about the like connection with the database and the secrets? So with custom containers, I think, let's see, I was looking for, this is, so right, yeah. So you can just pull, this is what I was looking for. You can pull this, with some limitations, you can pull Docker images from a registry. So it's very Python focused. You can totally like hack it to run other stuff, much like the code interpreter at ChatGPT you can get to run C if you're a clever prompt injector. But it is AMD 64 and Python. That's like, I think, a pretty tight limitation. So you can run it from like whatever you want. And maybe, I want to think, let's see. I've found like the base image is pretty solid. I think if you were going to do something off of like, Conda, then maybe you might want to operate off of one of the like, micro Mamba image or something with like CUDA already put into it. But I've actually found that running things just like adding, they have the official mini Conda 3 image as an option. You don't even have to pull it from a registry, and then you can Conda install. So I've also found even like pretty complicated installs where it's like I need bits and bytes, which has like strong opinions about my CUDA installation. I've been able to get it to work, all within the Python ecosystem. But yeah, great question. So that was about configuration of the containers. Mm-hmm. Yeah. Okay, so we will cover that when, in a little bit. So the question was, are you using like a vector database to store the videos? And the answer is no, unless you count a matrix as a vector database. No, actually, so there's a matrix index or a vector index based on face, but not a whole database. Or FICE, I guess, is how people pronounce it. So the second question was about secrets and that step of configuration. So there's secret management built into Modal. I found it like pretty easy to use. So you can have separate environments for production and development, and they have separate distinct secrets, and you do need to set them up. That is something that I think actually, let me just add a little quick Jupyter cell and show you that now. I think I do have a cell that does this at the end. So you can automate the secret production. There's also like a UI. So just send secrets up. It's like a key value store style. It's a little simpler than the like secrets management and something like Pulumi. So maybe they'll build out more functionality and make it more complicated. But right now it's like straightforward protected key value store. Great. All right. So I don't know if you've ever used the YouTube API, like the official Google YouTube API or its official SDK. Very enterprise grade, like you hit 7 endpoints on the way to just like getting a transcript. So we'll just pull the info that we need with requests, and just hope nobody's paying too close attention. So we've got a function that'll do this with requests, but we're gonna, rather than running it locally, let's run it on Modal. So we don't even have to install requests in our local Python environment. Basically, the vision with one piece of the vision with Modal is that you can just your local Python environment is always just like Python and Modal, maybe a few one or two additional libraries, and then like all the rest is executed on cloud infrastructure. So let's go ahead and run this one. All right, so here's it in action. The like white black background thing, that's a new VS Code bug, I think. But so it's what this is doing is creating containers. Mine is cached, so you don't see the container build step. The first time you do it, that takes a little bit of time, but actually extremely fast. I've used other cloud native development tools and often have churned from using them because it takes a very long time anytime I want to do something simple. And that has not been the case with Modal, real fast turnaround times. So pretty quick, maybe not quite as fast as running a simple function like that locally, but still reasonably quick. And we've got our MLOps World videos. So it also returns the information back to you. So a lot of stuff that focuses on cloud native development thinks like, oh, I want you to just do everything in my cloud environment. And they're like, oh, you want to have a terminal session? You should run your terminal session here. You want a Jupyter notebook? You should run your Jupyter notebook here. One nice thing about Modal is that it's about being able to serialize information, send it up. They do stuff, your containers execute, they return that information, deserialize it, and you have it back in your local Python. So it's easy. It's like there's maybe one piece of your shell script that needs some beefy compute or needs horizontal scaling, and it's push that up onto Modal and everything else lives locally. That's a nice pattern with this. So I mentioned horizontal scaling because we're just already executing in a container, and the containers are living on this cloud infrastructure. We can execute multiple containers concurrently without too much extra work. Just we've got a bunch of independent inputs, just spin up multiple instances and run. So there's a bunch of primitives in Modal for doing this, including a map operator. So I just take the exact same function, I say map, and I pass in a Python iterator, and now I am launching one container for each input here, roughly. And so we pull that. So now, I pulled the videos from one playlist. Now let's pull the videos from all the rest of the playlists. There we go. And we'll see our get transcript function is now going to run 1, 2, 3, one container for each of the playlists, and reasonably fast. I think the Wi-Fi's been a little, the internet speed has been slowing down some of this stuff, which is a bit of a pain, but yeah. So we have control over the concurrency there. Oh yeah, there was one other feature that I wanted to point out. There's a bunch of nice little bits built into these functions, which is like, I'm going to ping this API. It's actually not the official YouTube API. Forgot to mention this. It's a little pirate API, yt.lemnoslife.com. And, it does not have the same SLA as the YouTube API. And so, things fail pretty frequently. And you can add there, like in configuring the version of the function that runs on Modal, you can add things like a retry policy, like configured in Python, very straightforwardly. Not the hardest thing to code, but a pain when you just want like one little thing that you want to build or work on. Great, so that finished. Yeah, great.
Is that by design that you're using one container for each video, just to make it faster, or
yeah, so the question was, is that by design they're using one container for each video? I think in this particular example, there's not a great reason to do it because the work being done in any individual video is pretty small. I think if we were, say, like creating the subtitles by like running Whisper over the video audio, for example, or downloading the actual like video content, then you would want that. So that's a little bit more for demonstration in this particular case, just to show the flow. Yeah.
and if model automatically creates a container that will install it from the setup?
Yep. And to be clear, this is like their infrastructure, like somewhere under there, there's modals running Kubernetes and doing all of this stuff. So it's, so as distinct from like managing it on like my infrastructure on AWS, for example. So that is an important caveat. A lot of people like aren't able to put data in, some external service like that, or execute their apps in an external service like that. So that's probably one of the biggest caveats to using it. Great. So moving forward, let's get the subtitles for each video. Again, this one, just super tightly specialized Python library, like get, you basically, I think the call is, YouTube transcript API.get transcript. Very like nice, clean. It's been like pretty effective in my experience, and saves me from having to think hard about the YouTube API. Stays up to date as they change it, and so want to use that. So that was added to our container dependencies. Command keys not. So we can do the same thing. Now we're going to get the transcripts for each video from each playlist. And with that one, so there's now like 100 examples. We could do 100 different containers, but then we might hit like an API rate limit. And so there's, you can configure, among other things about the function, you can configure concurrency limits to make sure that you don't to help reduce the chance that you hit your, API limits. The previous one, I want to say the backoff coefficient was 2. What is it? Yeah, sorry. The question is, what is the backoff coefficient in the retry policy? Yeah, so the backoff the retry policy was an exponential backoff. So you try something, it fails. You wait for a certain amount of time. You multiply every time you fail. You multiply that by the backoff coefficient. So yeah, exponential backoff for retries. Yeah, again, it's fairly simple pattern, fairly common, but implemented nicely and robustly in Modal for the infrastructure. Okay. All right, so we get out our transcripts. Let's see. Yeah, and the transcripts provided by the YouTube API are the kinds of transcripts you'd want in a video, but where it's like line by line, and so like useful for displaying on top of a video. But with our language model, we want to grab this information and like turn it into something that looks more like a transcript than like subtitles. So like a transcript, like, you know, a written document. And so we need to like manage these. Again, there's a nice Python library for handling subtitles. Though this is a point at which thinking a little bit more about your data is helpful. So we've got this text and it's broken down by line, and we want to like merge it together into something that is that's longer for our language model. But we also want to, like right now it's time structured. It's structured on basis of like start time, duration. We want our language model will also benefit from having structure around the text, so like just dumping a bunch of text in like randomly chopped up and sliced is not the best way. So we want some other kind of structure for this text. We want to be able to like chunk it up together into like related ideas, and not just like 30 seconds, a minute, like some time-based chunking of the data. So the YouTube provides, for many videos, there are chapters that say like this is a chunk of the video that has a specific topic, and that that is sort of similar to like a heading on a web page that says like, you know, this is like heading level 2, you know, using the OpenAI API. And then, so you know that these are related topics. So whenever we can do that, we want to do that. So by like, you know, taking a look at the data and looking for this kind of extra structural information, that when I was working with this chatbot application, adding those extra bits of like, oh, this is a markdown file, it's got headers, let's parse this and break it down on the basis of headers. That was like a huge gain in the utility of the chatbot and the quality of its answers. So similar for this YouTube chapter, adding this YouTube chapter information. Okay, yeah, so gonna speed a little bit forward here because mostly this is just additional stuff that uses the same principles. Yeah. Okay. And lastly, let's get to the part about the like actual storage of this information. So we grab the information with out of its natural form. We need to load it somewhere so we can use it downstream in our application. The choice that I made for this project was MongoDB because it's web scale. It's a joke. You know, schemalessness is nice when you're like getting started with a project. Also, there's a lot of JSON-y stuff inside of LangChain and increasingly in language model applications thanks to OpenAI's function calling. So JSON is kind of a natural dialect for these things. MongoDB is like a very JSON speaks in JSON, BSON. And so like kind of there's less impedance mismatch. You could use any number of other potential solutions, like you know, Redis or Postgres. If you used, this gets back to, I think there's a question about like, wait, I thought when we do retrieval, don't we need like a vector database? Don't we need to do vector search? So we're storing our information, then we need to like retrieve relevant information for user queries. We're going to do that by turning the text into vectors, turning the user input into a vector and looking for their similarity. MongoDB currently doesn't have, outside of private alpha, a vector search. So that's one reason to not use it in this case. Redis and Postgres do have that feature. I think for most applications, though, using a database where the like vector indexing is like core offering of the database is not necessarily the right choice. The vector index is primarily used as a way to like search information. And it's easier to add a new type of index to an existing data store and add that as a different way of retrieving information than it is to take like something that is focused on that specific type of retrieval and then add a bunch of external information. So sort of co-locating the information with the other information that your application might need, like user information is maybe stored, session information is maybe stored in a database like Postgres, and having those things co-located is probably going to give you more lift than the maybe ergonomic benefits of using a vector-focused database. So we can also use modal to talk to the database, and that there's like a few little tricks in this code there for doing that, but that's not really the most interesting part of this. So I think I'll jump forward to our next step. Okay. Oh yeah. So one last point. I've been doing this demo in a Jupyter notebook just to be able to have like a nice little execution environment with multimedia. But this is MLOps World. What are we doing running code in Jupyter notebooks? I'm surprised nobody yanked me off the stage for doing that. You can also define not just you can define entry points for the stubs that you're building on Modal that run locally and then like execute some of the code remotely. So I've been doing like local execution with remote execution in the Jupyter notebook, but you can also just turn it into a shell script by adding one of these little registered entry points. And I think, I can just pull that up right here. So you get a command line interface out, and you define a little bit of like local operations. Then we've got these things that execute on the cloud infrastructure, both for getting the subtitles and then sending them up to the database. So this is the way you would want to actually do it, and it's the way that it's done in the make file, for example. It's pointed at these the local entry points turned into these little CLI scripts. Okay. All right. So where are we at? We extracted the information, took a look at it. Yeah. All right. So now we want to make that information searchable with by embedding user queries and comparing the vectors of user queries with the vectors that have been stored. So how do we go about doing that? Let me pull up relevant Python file here. There we go. Okay, so actually taking one step back, so we want to put up an application that can talk to a language model, can talk to an inference service, can also like retrieve information from our vector store or our document store. We can also do that using Modal. So it's not just for this sort of like scripting or ETL type workflow that we were looking at before. So the back end here for our application is implemented using Modal. I think it looks like a bunch of things like web endpoints where the Modal sets up something where you can like ping it with like HTTP in a REST style and like run some function that you've defined, like the let's see. Yeah. So we define our actual actual Q&A part, turn a query into a response. We run that on Modal's infrastructure as well, and this, we can ping that from another, like a web endpoint. We can run it as a Python function by using Modal's SDK. There's like a bunch of different ways to execute it. And we can wrap that up into like our final actual application. So yeah, actually just looking through this is probably the right way to walk through the application. So we've got we want to index our data. if you're anywhere south of like hundreds of thousands of documents, the like simple, easy way to do this is something like just storing them as a matrix and querying it with dot products, or using like a local vector index like Frye. So that's what I ended up doing. I think, let's see, vector connect to vector index. So it's really just there's a local file that is a pickled version of this vector index that gets loaded when at query time. But I think, yeah, the original version of this that I built used Pinecone, which is a specialized vector database. So we can see what that looks like. Yeah, env equal dev make vector index. This doesn't take too long. So let's see what that looks like. And let's see, app slash store to pi, I think, yeah. So yeah, so then you may have noticed mentioned in the code already, I'm using LangChain for a bunch of the pieces here. One of the nicest so LangChain, this open source library for working with LLMs. One of the things that I've found most useful about it, besides making some nice abstractions over LLMs and having some nice like built-in prompts, it also has connections to it has like built-in, ready-to-run versions of interaction with vector indexes. For example, creating like an index with Frye that includes the text information that provides an abstraction that lets me just call the embeddings and stores metadata alongside them. So I think that's what's yeah, nice. Okay. All right, so great. All right, looks like that step ran successfully. So where are we at? All right, so now at this point, after having created this like vector index for the data, a lot of people just sort of move to the like next steps. What I found is that like the vector index is actually like a useful way to look at your data, but a lot of people, especially people who came from like a software engineering background and an ML background, are unaware of like the ways to examine that data. So let's see, where did I put it? Experiments. No, not test queries, monitor. Yeah. So this vector index has now this like powerful representation of your data that we're like in the actual end application, you query it like, you combine the vector index with your information retrieval system. But there's any number of other things that you can do with those vectors. Like you may have seen, you can do like arithmetic with vectors, like combine two vectors with each other, or add a concept to a vector, and you can invert them. There's all kinds of different stuff you can do. The like simple thing that I'm going to do here is I'm going to use weights and biases built-in tooling to store a reduced dimensionality version of the vector information that so that we can like kind of examine it by eye and look for issues. And I found a couple of bugs in my initial app code by just like doing this by eye check. And so let's see what that looks like. So again, like we can define a new modal container, a new modal stub. And let's see, I made a make target for this, I want to say. Make vector index, no. No, I didn't make a make target for this. So yeah, so this one hasn't been fully written up. Do app.monitor log vector index. Right, okay, so this log vector index here. So this is, the other thing is, if you had one of these like fancier vector data, like specialized vector databases, you'd be able to say like, a lot of them like instrument additional stuff. Like they will project the embeddings down to a lower dimension and show it to you, or they will like refresh information about the database. You can, or about the stored vectors. You can like mimic a lot of that function by just using modal's ability to like run cron jobs, just like every once in a while kick off one of these like kick off one of these executions that we were running by running Python code, but run them on a schedule instead. So this little vector index logging code, which I'll just run right now. You can see this running in the terminal. Takes the just like grabs the embeddings, just like scans the whole index. You could subsample if you wanted to, if you had like hundreds, thousands, millions, billions of vectors. Takes that and turns it into a state table and stores it on Weights and Biases, the experiment tracking platform. So what I like about using this tool, like I came out of the like ML research world, where Weights and Biases is pretty popular for managing like the creation of models. There's a bunch of nicely built-in tools for, say, like storing these vectors, projecting them down to a low dimension, and then like interacting with them live here. So let's go to a previous run, and let me show you just like an example. There's the outlier embeddings example, and yeah, so this is one like previous iteration. Land in. Come on. Oh yeah, these are beefy, so it might take a minute to load. There we go. Okay, yeah. So, storing that, like when I logged all that information up here, I get this nice like tabular view of the like not just the embeddings, but also the like associated text with the embedding, the source, and I calculated a few little metadata columns here, and then I can like from this like raw table, I can add additional information. For example, this table down here is constructed by taking the so I was looking through this and I was seeing like there's there's YouTube videos and there's papers, but there weren't any of the lecture note sources weren't being stored. So one way to discover that is to go through and rather than like take the information that's been logged up to this logged up here and calculate the like most relevant piece of information for discovering your issue. So like exploring through it, let's say. Yeah, I can run, let me just do this. Yeah, insert one right. So I noticed that they were all paper or YouTube. How did I notice that? I was looking through, or how could I confirm that if I see it just like examining the data by eye? Go ahead and just calculate, is this from a paper source or is this from YouTube? And calculate that, and then just do a quick group by, and discover that this Boolean, which is like, is it a paper or is it a YouTube? This should sometimes be false if it's coming from one of my other sources, but actually all of them are true. There's only one group in this group by. So rather than having to like calculate all that stuff ahead of time, I can just use this nice flexible query language that Weights Biases recently open source called Weave, to like calculate the most like relevant piece of information. So maybe another good example. I logged the vectors up and got a low dimensional representation of all the vectors in my index. And there's some neat patterns that are a little bit more like data science-y that you can pull out here, like the YouTube videos, including like a bunch of stuff from the MLOps World videos, like these hands-on workshops, intro to MLOps. This stuff is all, one of our principal components is like, is it a YouTube video, which are the red and blue dots, or is it a research paper, which are all these pink dots over here. So we can see that nice and easily. But then second thing that jumped out here was there's this large chunk of data that's up here that is that looks like very different from the rest of the data. It's like there's like a discontinuity here in our embedding space. So let's take a look at that. So again, like just build up one of these tables from scratch where I grab out, okay, let's grab this. Looks like all of them, like by interacting with this, I look at them and I see, oh, well, these seem to all have the same title, towards a unified view of parameter efficient transfer learning. Let's just filter the stuff that we stored on for things that have that title, and then take a look at their actual text, and we can see, oh, this is not what I was expecting to be storing. This doesn't look like text that could be useful for a language model answering questions about MLOps. This looks like base 64 encoded text, or base 64 encoded binary data. And if we look around, I did a little bit more, exploratory data analysis here, calculating the number of times that any particular, like one of these weird strings appeared in this, in the data from this source. And one that showed up a lot was LaTeX. So the output of LaTeX in this case was full of binary data. So that paper has added a bunch of trash of binary encoded data that we don't care about to the vector index. So we might want to, using this kind of exploratory data analysis, we can uncover issues with our stored data that might otherwise we'd have to wait until some user is like, wait, why is the language model spitting out a bunch of random gibberish, right? So being able to when creating your document store, when creating a vector index, being able to use that new search capability that you have to look at your data in a different way, access it via both the query patterns of the application and novel query patterns like the ones that I'm writing here, allows you to uncover issues and build in the end a more robust application. I think, let's see. So that was the monitoring one. Oh yeah, and then what did I do with the test monitor? So a lot of people ask, how can I test these applications? How can I figure out whether they're working well? There aren't really that many great answers, but one pattern that I like is just coming up with a couple of basic queries that you can use to probe a behavior that you're interested in. So for example, this is a chatbot that's supposed to answer questions about MLOps and large language models. It probably should not answer questions about how to manage stress or what the meaning of life is. But it should answer questions that are how is MLOps evolving with the advent of foundation models? How do you calculate the ROI for an MLOps implementation? So I generated all these queries, these sample queries, by coming up with 10 or 15 myself, and then asking a large language model to generate more examples. And then so there's a couple of different ways that you could use this. You can use it for the exploratory data analysis to let's see, I think I have an example, a little report on that. Yeah. The other thing, and what I actually meant to show with this example is, so we're running we make our vector index, we search over it, we take the user query and compare it to all the examples in our vector index, and we get back the sources, and we get back also scores of how similar or dissimilar the document was to the user query. And with a vector index, it's always going to try and return some information. It's going to return the nearest neighbors of your of the input, but those neighbors might be actually quite far away, subjectively in their semantic content, or objectively in the numerical value of their similarity. So let's you might want to filter or threshold, right? You might want to add a little, the same way that we add filter clauses in a SQL query. So I do filter in this example, where I've got my sources there, I've got their scores, and I grab only the ones whose score is less than 0.4. And so there's just this magic number here. Where did that come from? So doing stuff like these test queries is how you can like build evidence for the use of a value of like these magic numbers. Pretty common. The need for these kinds of magic, constants is pretty common in ML. Maybe surprising coming from elsewhere in software engineering. Let me pull up the experiment I ran to do that. Yeah, threshold setting for vector index. Okay, so let me quickly show that experiment code. I think that will be helpful. Yeah, again, we'll run this experiment where we like take those fake user queries and that we've annotated with special metadata that says, is this a relevant question or not a relevant question? And we'll just embed all of them and log like the scores that they got, and yeah, log query results, what's in that query data frame. Yeah, the texts, the scores, the like metadata about them that might be helpful for kind of like figuring out what are sources that frequently come up for irrelevant queries, what are sources that come up for relevant queries. So we're gonna like calculate all that information and log it on WNB, again using modal to run these experiments so that we can like parallelize them in whatever way we want. And so what I found when I ran this was that if I look at the distribution of scores for irrelevant queries, I can see that the scores are they're like the lowest score is about 0.3, the highest scores go up above 0.5. Large means less similar. So this is like a measure of distance between the user query and the source. So the user queries that were irrelevant gave me larger numbers. And I can specifically compare like directly here, built this table by doing a group by. So yeah, group by relevance, great. And then like sort of customize a little bit this histogram chart. Like I know that these numbers are between 0 and 1, so I want that. I want a nice number of bins, so I like have a clear view of the distribution. I've also got some of the like raw data here, so I can always drill into the raw data that's constructing these charts. This is what I like out of my like data visualization and exploratory data analysis tooling. Yeah, and if you look at it, you could probably make this a little bit more objective of like trying to like maximize the probability that you don't like I guess you would have to think like, okay, do I want to maximize the probability that I respond to relevant queries, or do I want to minimize the probability I respond to irrelevant queries? So you could make that a little bit more objective by setting like your desired false positive or false negative rates. But just looking by eye at this, it looks like at about 0.4, there is almost like above 0.4, there are almost no relevant questions that that match a source with a value lower than 0.4. And there's lots of irrelevant stuff. Also, we can see it looks like some of those like gnarly examples, like these like base 64 strings, are like frequently come up for our irrelevant queries. So yeah, we might want to clean those up. The other fun thing is we can also sort of like query what are the actual examples that had the lowest distance scores for our relevance stuff. So, for example, one of the irrelevant queries was like, what is the capital of Australia? I don't need my MLOps chatbot to answer that question. And if I look at this is the one that got the highest relevance score when compared to a document. And technically, I labeled that as an irrelevant question. And so I was claiming that this document should be irrelevant to that. Turns out one of the papers that I indexed used what is the capital of Australia as an example question for an LLM and showed the LLM's response. And so it shows up as like these are very semantically similar vectors. So what that kind of suggests is that anything below 0.4 actually is it is something relevant to the question. Whether the language model should actually answer that question is maybe something to like kick off to the like downstream actual like cognitive modules and not the retrieval component. So it seems like that's like good evidence that are like our threshold somewhere here between like 0.35 and 0.4 is capturing the distinction between is this relevant to the question and is this not relevant to the question. And yeah, so like working on that kind of this. So I focused on this like managing the vector index and sort of like probing it as the way to improve the retrieval quality. I'll say like the other like large dimension there is just general information retrieval techniques. So like re-ranking, a lot of ideas from recommendation systems, and like mixing in additional metadata. For example, like if you know a user's geographical location, maybe you have distinct like localized versions of the sources in a different geographic location. And that sort of non-vector based information can also like substantially improve the quality. Yeah, that's distinct dimension that we aren't going through here, but you'll see a lot of people talking about for how to improve that retrieval step. Yeah, any questions before we move forward to the actual chatbot component? Yeah, it's just a local, like the vector index is all local, but yeah. Mm. Mm-hmm. Mm. Oh yeah, so the question was really the like fundamental thing that I'm embedding is just the string, like that I am embedding, and you're saying like, oh, I have an actual JSON document, and that's the thing I want to embed. Yeah, that should work actually pretty well, especially with OpenAI's models. A lot of they like use JSON for a lot of features of their models, so I would expect them to actually have like pretty good representation of JSON. And you should, I would say, in that case, if you that's a case where the like combo with classic IR is probably a good idea. Like there's likely to be like JSON's structured format. You can probably pull out structured information that helps you respond to that user natural language query. Like I might do that not just by vector indexing, but also take the user query, extract structured structured things like, oh, they're asking about only this kind of document that has this key, so only retrieve documents that have this kind of key, and mix that with the vector index the way you would mix like relevant scores from multiple sources. I think in like classic database world, those you would only use like logical connectives. You would use like and or, and you would use like something softer here. It would be like, you know, the score comes out of the vector database. Let me like add the score that comes out of like the information retrieval, like multiplied by some factor. Yeah, I've seen that for. That's how I want to say Weaviate queries are kind of like built that way out of like combining these scores. And yeah, and Redis as well. Definitely, the vector index returns a score that's meant to be combined with other kinds of retrieval scores, and that should work well. Yeah. And then to set those scores, I would say you would do a process like one that I just showed, which is like take some example queries, look at the numbers, like look at a distribution and either eyeball or calculate a cutoff. Mm. Yeah, happy to chat with you more about this specific application. Sounds interesting. Yeah, all right. So let's get to the actual part with the chatbot. Okay, so we did the vector indexing. So let's do. So we'll also run the. So we've got this basic. Like a Python function that takes in a user query and returns a response from a language model. And I guess let's should be able to. Query. Yes. So anybody got a MLOps question, a favorite MLOps question they want to ask, just to show we got this thing up and running? I could come up with one, but then you won't trust that it's not a cherry-picked example. Ooh, how much data is too much data? For anything in particular? Just in general? In general? All right, we'll see what happens. I bet it says like, I'm sorry, but I can't answer that question. But we'll see. You know, it's a hard question. Oh, we got to have to activate my Python environment. Come on, baby. Dang. Okay, that's what I get for trying to do. Oh, right. Ask. Yeah, I think Python 2 is pretty much deprecated at this point. Yeah, the question was about Python 2 versus 3. I think, yeah, the most recent, for a lot of Python focus has been on the performance, in the latest versions has been on typing and on performance. Most of the time, Python is not the performance bottleneck for ML stuff, so that means less reasons to adopt the most recent versions. The typing stuff can be nice, especially if you're running web appy things. Okay, so we're now running our application here, running our query about how much data is too much data. Okay, so we got our answer. The concept of too much data is context dependent. It can lead to analysis paralysis if not managed properly. Wow, this is a very thoughtful answer. The cost of maintaining updating models of real world data changes should be considered. Return on investment for the amount of work for a given model is producing should be evaluated regularly. Here's our sources, pointing to like an MLOps
So that's
video.
what we're assuming about the problem. What about the solution? First, we want to be problem focused, right? So this is similar to what I'm saying about first principles.
Interesting. So this chunk is sort of like maybe not specifically talking about data quantities. We can maybe scroll up a little bit in our logs. Oh no, separate log where that is stored. Yeah. So that was our source there. A particular chunk of that MLOps World YouTube video. Yeah. That one we can see. It's like giving some general advice about how to solve problems in MLOps, and that like is being used by the language model to give this answer. Maybe ask that question again when I am in an environment with better logging. So speaking of which, so we've like to actually deliver this model to users, like you want to like have a nice UI for interaction. So there is in this in the repository, there's code for deploying to Discord as a Discord bot, and that's where the like production version lives. It is, yeah, that. But rather than focusing on that part of it, which is always like very application dependent, like what's the actual interface that you want to deploy stuff in, I want to focus on a pattern that I really like for improving applications, like ML applications in general, which is making like a minimum viable UI that's easy to spin up for like every time you change something about a model and interact with to get like to do like kind of smoke tests by hand or with like, you know, a small team. Where like maybe, you know, like with Discord, for example, like if you want to have a separate test Discord bot for testing the Discord stuff, it's like a whole nother set of permissions. You need to probably like put it in a separate channel. It's like very heavy weight, and you know that's like and it would be like it's going to slow down your velocity a lot to make that the way that you do your like interactive testing. So what are the alternatives? So the way that I like to, so people are maybe familiar with Streamlit as a solution to this problem of like taking a little bit of Python code, wrapping it up into a user interface. There's a newer library that I really like for this called Gradio. So Gradio here is now part of Hugging Face. So Gradio takes advantage of some recent improvements in Python, which is the addition of an async runtime, which makes building like a scalable web service a lot easier. And it allows them to do something like a little bit closer to like a React kind of execution model where you build out little components, and only the components that are being interacted with the user are re-executed on each interaction. So if you've ever used Streamlit, you know that like anytime a user like clicks a button on a page, the entire Python script that defines your application runs from top to bottom. And so you have to build your own like kind of caching system. They provide some tools for it, but it's like pretty heavyweight. It's I find it like hard to think about because there's like a lot of caching and cache invalidation you have to do by hand. It'd be like sort of like managing the React like virtual DOM by hand, and that is very hard. There's a reason why people use frameworks for that, and Gradio lets you avoid that and write something that's like closer to normal Python. So just to define a little quick user interface, we build like we give some headers. We define a text box that lets users type in their question. We have a text box where the answer appears, and we add some buttons. And the buttons are all like sort of, it's like callback kind of themed. So you're just passing around some Python functions to these buttons, and it's a lot, especially if you have some experience with web development. It's like a more straightforward way to build these little tiny UIs. So let me show you what that looks like. So the end result is something that looks like this. So we got our headers, we got our question. Let's toss in that question that we had before, that CLE query. How much data is too much data? Here. And the nice thing, like this, obviously this is not something you would like, put in front of users. Like it's very demo-y, but you can spin these up very easily. And then, like if you're using something like Modal for hosting, which is what we're using here, then you don't have to pay any money to keep this thing up. It's fully like serverless, scaled to 0. And so you can say every time you run an experiment, you spin up one of these things. And then like every time you make a change on every Git PR or whatever, you spin up one of these things. And anybody reviewing your PR can go in and interact with this and see like how has the behavior changed. And so that includes like, for example, non-technical stakeholders. So I've found there's a large fraction of the like P0 kind of issues with ML models that are best determined through like human interaction, and rather than the like, quantitative evals. So this can be a very powerful way to discover issues with your system. And yeah, so the easier you make interacting with a thing and spinning up an interactive version, the more you'll be able to take advantage of that. Okay, so all right, so we got the same answer here. I wanted to do that so that I could show the the logging features that have been added to this. Let's see, do I have? So we had that question, like how much data is too much data? Let's pop in here to Ask FSTL backend. This is the modal interface that has all the like logs for our app. Let's see, Q&A. So this step is intentionally a little bit painful. I'll show you a better way to achieve what I'm trying to achieve here, which is look up that specific query that we just saw. That was in dev backend dev. Okay, yeah. So that would be this guy. All right. Okay. So with the logs on this one have all of the sources included, so we can take a look not just at the like YouTube video source that we were looking at before, but the actual specific chunk of the content that was actually retrieved and used. All right, so this one actually does say a little bit about size of data that's sensible for working with tabular data. And this is where it looks like we can see here, this uses the phrase analysis paralysis, which we saw showing up in our model. So models tend to kind of like repeat stuff that appears in their context. You can take advantage of that with prompt engineering. You have to be careful with that with retrieval if you don't have good control over the information that's being retrieved. And And let's see, looking at this example, this one's talking about GPU scaling. Is there anything there that seems similar to what the model said? Yeah, I don't see anything in particular. Eventually refine the models to do what you want. Business owners trying to figure out whether or not the return on investment is sane for the amount of work that a given model is producing. So yeah, it seems like what happened here is the model kind of picked up the vibe for an answer from these things. It didn't have the actual answer in it, and then it gave like a guess at an answer to the question based off of the like phrasing and style of these, talking about return on investment, talking about analysis paralysis in this final answer. So this is kind of an interesting kind of edge case. It's like there was useful information for answering in the retrieved context, but not the answer. So depending on the type of chatbot that you're building, that's either a good thing or a bad thing. And you'd want to do maybe some prompt engineering using an example like this as your test case if you want it to not answer in that case, because there isn't a literal answer to the direct question. So if you're building something that's like a support bot or a docs bot, maybe you want to make sure it doesn't ever like answer any questions except what's literally in the context. Or if you want something that's a little bit more friendly and will answer like kind of general questions, which is how I approach this particular chatbot example, then you're fine with this behavior. So to express that I'm fine with this behavior, I clicked the thumbs up there. What does that do? So LangChain, in addition to helping abstract the LLMs, giving some nice basic like prompts, some like types for interfaces between components and these existing integrations with things like vector databases, they also have with Langsmith, they have an LLM observability product. It's still in beta. If you're interested in this, talk to me and I'll see if I can help you get a hold of a beta key. But what you can, like, just by setting a few environment flags, all of the traces of the executions of your models running with LangChain get logged to Langsmith. There's a bunch of stuff that's like kind of more engineering-y, like what are my P50 and P99 latencies. Got a pretty gnarly P99 latency on this one. It's, serverless cold boots, the OpenAI API, really long sources. Not bad on the P50. So there's some some more engineering-y features. But what's like sort of more valuable is the ability to inspect the examples as they're coming in, and view things like the feedback. So let's see, I think we did a thumbs up on that one. So let's filter by that. So there's our question there. Let's make the input column a little bigger. How much data is too much data? And let's pull this over so we can see it a little better. So now we have not just the information, like we have the information that went to the model stored in our log, so we can see the like actual prompt result. And we could also dive in here. I think if we dive in here, we'll see, this is something closer to the actual text. To look around to find the actual text. But this is like a structured version of it. That is what was pulled out of the vector index that has things like the metadata. Sometimes can be a more useful way of looking through this stuff. The feedback here is stored like that, that thumbs up that I gave it. And I can also annotate and add additional information. Like I can add some little like notes to self, which is like, interesting edge case, model got the vibes for a good answer from the sources, but they didn't actually have the answer. And you can collect up this information and turn it into data sets like the example query data set that I used to set the relevance scores, or set the relevance threshold on the vector index. So I can add this to a data set. Let's make a new data set for this one, and we'll call it like, edge cases hallucination, because like, is this a hallucination? It wasn't in the context, but like, but it wasn't completely made up. And create one of these. Now this, like, you can export this in any number of different formats, including like the JSON lines format for the test queries. Okay, so this what I wanted to try as our last step here was to actually have a little annotation party with this model. So if you scan this QR code or go to that short link, you'll be dropped into that interface there that I just showed you. And what I'd like you to do is like ask some questions about MLOps, maybe something, if it's from this year's MLOps World, unfortunately, I've not indexed that data yet, so it might not know about the latest features from Aporia or whatever. But if it's something from the last couple years of MLOps, higher level questions about like Kubernetes and scaling, it should be able to answer questions like that pretty well. And it will also probably make some mistakes because we're still in the like iteration and engineering process with this. So go ahead and ask questions about like maybe some of your like favorite topics, like try and stump it and give it some thumbs downs. Actually, one thing, if you speak a language other than English, try asking questions in that other language and we'll see what comes out. And then, so while y'all are doing that, I'll be looking at the like Langsmith logs and try and like pull out some like patterns from things that people have done with their with their queries. So yeah, make sure to smash that thumbs up or thumbs down button as appropriate so that it gets logged up and I can check it out. All right, I haven't seen any feedback yet. Has anybody not been able to get it? Oh, yeah, that's been happening to me on the hotel Wi-Fi, where like I can't get to google.com on the hotel Wi-Fi, and yeah, bummer. Loading? Okay. Bummer. Okay, yeah. All right, so it's not, there's also some, yeah, I had to turn off the concurrency because of a strange state bug. So I'm worried that maybe with 10 or more users at once, it might take some time to load. Let me see. Oh, yeah, try hitting refresh 10, 15 times. We'll see what happens. Yeah, let me check. Let's see some, yeah, level good. I meant to do a load test, but I was like, you know what? It's serverless. It'll scale, obviously. Yeah, let's see. This should be into still backend. Let's do some. Oh yeah, I should turn back on mirroring so I can look at it on my screen. All right. Alright, that's gonna still back in. I'm not seeing errors. There's a fast API app. Alright, here's everybody coming in. Status pending. Okay, yeah, that's no good. Yeah. Okay, yeah, so just looking at here, so jump into so people are saying they're not able to access it. Let's jump into the app logs. Here's that fast API app, this specific component. There's other pieces that could be getting executed. This is the one that y'all are hitting. We see the big traffic spike right there in the little spark line type thing. We see here information. Okay, so it's not that we're like running out of, of CPU or RAM. I think, yeah, there's lots of space there. There's only one instance, and I'm gonna guess that is the core problem here. It's trying to serve all of like everybody at once, and I've seen that work well in the past, but I hadn't tried it with this particular one. And yeah, that was a last minute change when I noticed that user sessions would sometimes get like put onto different workers, and then when they tried to like log, they would log for somebody else's. You click a thumbs up and it goes on to somebody else's interaction, that's no good. You don't want that. Okay. Anybody been able to get in? No? All right, well. All right, okay. It does run. Yeah, here we can see it takes a long time to load. Bummer. Okay, well. All right, I got to file a bug report about that state issue. Yeah, well, I guess we probably won't be able to do the annotation party. So let me just give some of the color around that. Where's my Google Slides? Where else? Yeah, so okay. With things like this annotation party, the idea is that like there's a temptation to take this kind of work and like outsource it and like make it just the work of users, or like create an annotation team that's like crowd workers or external contractors or whatever, and do a process like what I intended to do here as like this external kind of like secondary QA thing with but I think the most like successful teams that are building these applications, they like marry these two organizations as tightly as possible. Like at the beginning, it's like one person who's building this system is also kind of like the only user and is like annotating, tracking, and like issues with the system and improving it. Over time, like that, there's like a broader team working on it, and at that point, you want to do something like make this kind of like annotation interaction part of your PR process. Like part of your like rotations or pager duty kind of thing, where it's like drop in, like interact with the model, or drop in to like do, so that would be fulfilling the role that you would be doing of querying the model and giving feedback. Then the other thing to also like usefully include in your rotations or your on calls is looking at the user data and searching for interesting patterns. Trying to like automate that process with language models or outsource that process, you're going to get way lower quality results, and you won't be like getting that information and internalizing it into the engineering team, who are actually the ones like most capable of fixing those issues or like deeply understanding the system in order to resolve those issues. So was hoping to get a good demonstration of that, but looks like we don't. We won't have that, but the code for all of this is on that GitHub repo, including a code space where you can execute it yourself, try it out, and happy to take any questions with the last minute or two that we have here.
A quick question regarding how you create the data.
So the question was, how did I pick the chunk size? Yeah, okay, so I kind of glided over that one. So there's, I think, two distinct things that you need to solve. One is like when you get a hold of the data in its raw form, it might not be like semantically well structured, like the subtitles. So there, it's like understand the data source and figure out how to break it down cut it at its joints. Where are the natural breaks? And you probably want to use something like, if you check out Llama Index, they have a lot of more complex ways to index data where you have like a hierarchical separation of data. So then you might want to have a document that represents like an entire like chapter, and then underneath it, also stored in the same like tree, are all the sub chapters, right? So that there's that problem. that's distinct from the problem of breaking something up small enough so that it fits in a language model's context. So if you are using a long context model, which I think a lot of people are using, for retrieval augmented generation these days, like a 100K model from Anthropic or the 32K models from OpenAI, you can fit a decent amount of information. And so it's less, often when you cut things up by their chapter, subchapter, their like subheading, you'll find that it fits, the individual pieces fit pretty well. If that doesn't work, then you have to like parse the document and break it up smaller. So that was another thing that LangChain got used for in this project, was they have some nice like basic text splitters that are like, first try to split the text on double new lines, or double new lines with like, a header or something in between them. And then if that doesn't work, fall back to single new lines. If that doesn't work, fall back to periods to split by sentences. If that doesn't work, fall back to just splitting on spaces or in the middle of words. And that, that's another thing where you want to like examine your data and look for like common patterns of how thoughts or concepts or like relevant pieces of information are separated in the actual text. Maybe it is double new lines. Maybe it's like triple new lines. Maybe if it's code, it might be something closer to like parsing the abstract syntax tree and like using that to determine how to chunk the stuff up. I think you can see that in the like reverse engineered Copilot code. So yeah, there's a bunch of different approaches. They're like a little bit last mile, but there are some general patterns in things like LangChain and Llama Index that you can borrow. There's another question? Mm-hmm. Yeah, so the question was a very good one, which is if you're just embedding the question and using the same embedding model to embed the question as you used to embed the answer, shouldn't those be pretty different, right? Like, shouldn't those be far, like they are not necessarily semantically similar? And that's correct. So the quality of, what I would say is that like, generally, there are like topic words, ideas that are in the sentence. Like, how do I use, how do I use Ray on Kubernetes, to pick an example from the, how can I use Ray with Kubernetes? So like the words that are in there are similar enough to the words in the answer. Like the answer is going to have to mention those things. It's probably going to mention a bunch of words that are similar to them, right? Like an internet scale trained embedding model is probably going to know that any scale and Ray are related to each other, and that like Kubernetes and like cloud native and Docker and Pod are all semantically similar. And so it works better than you would think just out the box with generic embeddings. One example that I kind of cut out for time is you can learn to do so you can use cross embeddings, where you like take the query and then you pass it through, like take the embedding of the query and you do a linear transformation or like cheap small transformation to try and make the embedding of a question more similar to the embedding of the answer. And you can so the way I would do that now is I would take a bunch of the examples that have gotten thumbs up or that I have liked or that like I've seen good user interactions for, collect all of those up and then use those embedding pairs to like train a new little custom embedding model. And there's an awesome OpenAI cookbook example on how to do this that walks through and shows that you can get like really good improvements to performance with like 100 user queries as examples. So you want positives, like negatives, and and mine a few hard negatives, and put that together into a collection of like 100, 200 examples, train that little cross embedder, and you'll see improved performance. Yeah. Yeah, so the question was, I was using OpenAI embeddings. Are there any open source alternatives? So two answers to that question. One, OpenAI embeddings are like super cheap. They're insanely inexpensive. I think it was like definitely under $1 million to embed all of Wikipedia, like just going chunk by chunk. Um, hmm? Yeah. So that said, so a lot of people when they see a managed service for something like this, they're like, I bet I could save a bunch of money by running it myself. What's the open source option? In this case, it's going to be hard to do it yourself, but and for a long time, I think there weren't comparable, like very generic embeddings. Like you could maybe find somebody who had trained a model on code that did embeddings that would like do just as well on that domain as the OpenAI embeddings. Just recently, I want to say it's Gin AI embeddings. Gin AI? Gina. Yeah, Gina AI embeddings. This is like this week, I want to say. That people have gotten excited about. They have some very good benchmark results. They were trained on a pretty large data set. I believe they also have like pairs of queries and the resulting documents, so they don't have the problem that the previous question addressed, which is like, how does a question look similar to an answer? They've been trained as cross embeddings from the start. So I think a lot of people are excited about Gina AI, and I definitely have it on my list to like swap them out. And then you want to run it yourself, you could, like for small scale, you can just treat it as like send a thing, get an embedding back. For a larger scale, you'd want to do like batching, and you can batch these pretty effectively even on, and like on a small cheap GPU, like a T4 or an A10, you could like do, you could probably like saturate that with reasonable size batches. Yeah. Great questions. All right, I think we're already even over time, so I'm happy to stick around, answer questions. Thanks everyone for coming.